here in the shortcut method. The next case is the divisibility by 4 and 8. So let's see what are the conditions which apply for identifying the number to be divisible by 4 or divisible by 8. So initially I'm going to start with divisibility by 4. So in this case, so let's see what the condition would be through the definition. The rule in divisibility by 4 says that a number n is said to be divisible by 4 if the last two digits of the number is divisible by 4. So the last two digits of the number, however big or small, is entirely dependent on divisibility of 4. If I have my last two digits picked from the number and I just see that the number is divisible by 4, that two-digit number being divisible by 4, then indirectly I can say that the whole of the number is divisible by 4. Let's see through an example after the definition. So a number n is said to be divisible by 4 if the last two digits of n is divisible by 4. So let's take this with an example. For example, I have 2184 and I would like to know if this number is divisible by 4 or not. In this case, I take the last two digits. So when I pick the last two digits, I identified that in case of this 4-digit number of the example which I have taken here as 2184, the last two digits form a two-digit number 84, as can be clearly seen from the number. So when I pick the last two digits, when I get the number 84, my definition says that if this number is divisible by 4, then the entire number which is attached with the last two digits indirectly is also divisible by 4. So clearly we can see that 84 is divisible by 4 because the last two digits, when I just divide with 4, would get me 4 2s 8 and then 4 1s 4, such that the remainder here is 0. Then in this case, I clearly find that 21 times of 4 is 84. Therefore, this one multiplied to this being equal to 84 clearly makes me understand that 4 is divisible by 84. Or I'm sorry, 84 is divisible by 4. Therefore, since 84 is 21 times 4, therefore 84 is divisible by 4, as can be seen in case of this proof or the working which we have taken here. Now because the number, the last two-digit number, that is 84, is divisible by 4, therefore I can say by this definition that therefore 2184 is also divisible by 4, strictly with the last two digits being the same. And this is how we identify the divisibility by 4. It's very simple. Pick the last two digits, identify that two-digit number, whether it is divisible by 4 or not divisible by 4, and then that will indirectly make us understand that the whole number which is associated with the last two digits which are picked from is also divisible by 4 if the last two-digit number is also divisible by 4, is how I understand the divisibility rule of 4. So let's take next case where I can see divisibility by 8. Now as we have the condition for divisibility by 4, there's a similar definition or the rule which is applied for divisibility by 8. But the only difference being that here I pick the two digits, the last two digits, and here I pick the last three digits. So the whole of the definition of divisibility by 4, which is picked with last two digits, the similar is the definition for divisibility by 8, where I pick the last three digits, and if the last three digits of the given number is divisible by 8, then the whole of the number is indirectly said to be divisible by 8. And that is how we understand the divisibility by 8 rule. So the definition is as similar, but step 1, I pick last three digits of the number. I pick last three digits of the number Then my step 2, check for its divisibility for 8. Check for its divisibility by 8. So I just check whether the picked 3-digit number, the last 3-digit number, is divisible by 8 or not, by randomly using the division process as I have used here. Then step 3, the given number is also divisible by 8. If this is holding, then this indirectly says that the given number is also divisible by 8, is how I understand the 3 steps which are involved in checking for divisibility by 8. So let's take an example problem and use the 3 steps in identifying whether the given number is divisible by 8 or not, however large or smaller the number is. Now let's take an example problem and check for the divisibility by 8 for the given number. So in this case, I have taken an example problem where I have such a large number, including 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 digits. The number is a 10-digit number, which I would like to identify for its divisibility by 8 by directly using the shortcut process, which involves 3-step processing. So in the step 1, pick the last 3 digits of the number. So I go with the step 1 where I pick the last 3 digits, 1, 2 and 3, coming from the last unto the first. So when I pick the last 3 digits, the number formed is 184. So this is my last 3-digit number picked from the last 3 digits, and I want to next go for the step 2, which says that check for its divisibility by 8. Now because I want to identify whether this number is exactly divisible by 8, now since this being a 3-digit number, I can randomly go to the next step where I can just randomly divide this with 8 and see if the remainder is 0. So let me just start with 8, where 8 2s is 16, then one subtraction it is 24, and then 8 3 is 24, where the remainder is 0. Now because 184 can be written as 23 times of 8, therefore this clearly makes me understand that this number is divisible clearly by 8. Multiplied 23 times gives me exactly 184. So because of the factor form, this number is clearly divisible by 8, and hence my step 3 says that the given number, if it is divisible by 8, the condition is the last 3 digits must be divisible by 8. Therefore by step 3 I can conclude that the given number is also divisible by 8. Now since this is divisible by 8, therefore I can say that clearly by step 3 or by divisibility by 8 rule, because the last 3 digits are clearly divisible by 8, therefore the given number is divisible by 8. The given number is divisible by 8 is how I understand the divisibility by 8 rule. In this case, taken with last 3 digits, and I understand divisibility by 4 rule taken with last 2 digits, and those 2 will be the deciding factor for the divisibility of the whole number indirectly through a shortcut process. Now this has a limitation where the divisibility by 7 rule in case of my first case is derived only for a 3-digit number. What happens when I take a 4-digit number or a 5-digit number or anything more than 4, 5, 6? So in this case, you don't have a fixed rule for any digit taken out there or any number with number of digits increased there. Therefore, divisibility by 7 concept is with its own limitations, where my derivation for a 3-digit number had the condition that 2a plus 3b plus c must be divisible by 7. But what happens when I have a 4-digit number? So we need to identify a derived formula where we proceed with the similar steps, because when the number is a 4-digit number, then it can be expanded in multiples in expanded form as 1000 times of a plus 100 times of b plus 10 times of c plus d, is how the number of variables increase according to the digit which is considered, and then proceeding with the nearest and with the same steps as we have proceeded for a 3-digit number in identifying the nearest multiple of 7 near to 100 and nearest multiple of 7 near to the 10, etc., is what I proceed with in identifying the derived formula for a 4-digit number which is divisible by 7. The method of construction is the same as we have done for 3-digit number in identifying the number for its divisibility by 7. 3-digit case being this, 4-digit case also can be modified in the similar manner. Even 5-digit number or a 6-digit number, etc. Now the last concept of divisibility rule is with divisibility by 11. So let's see how we identify the divisibility by 11 process using a rule. Now in this case, we have a certain step processing through which we identify the number for its divisibility by 11 or not. So in this case, let's start with step 1. So let's take step 1 where I consider summing up all the digits at odd places taken from left. This is my step 1. I sum up all the digits which are picked from the odd places, first place, third place, fifth place, seventh place, etc. taken from left to the right. Now my step 2 is also with a similar step, proceeding in taking all summing up of the digits at even places, where step 1 is taken care of with odd places and step 2 is taken care with even places, both taken from left. So let's see with an example how we can do that, but let's first understand the steps. Now my step 3 includes step 1 minus step 2. I do the difference. So whatever value I obtain in the summing up of all the digits of the odd places and whatever value I get when I sum up all the digits of the even places taken from left in both the cases, the value which I get on difference will be with the step 3. So I do the difference of the value as obtained in step 1 and the value as obtained in step 2. So this minus this is the difference, what we call. My step 4, check for the divisibility of the difference which we have obtained in this case. The difference which has been obtained in this case by 11. So my step 4 says that we have to check for the divisibility of the difference as obtained in step 3 for its divisibility by 11. If the difference is divisible by 11, then the whole of the number is indirectly said to be divisible by 11. And that is how the divisibility by 11 rule is understood in case of this. So therefore, the whole number is said to be divisible by 11 if the difference is divisible by 11. And the difference is the difference as obtained in step 3. So the whole number is said to be divisible by 11 if the difference as picked from step 3 is divisible by 11. So this is how I understand the divisibility by 11 process through step 1, step 2, step 3 and step 4. So let's take an example problem where the example problem is proceeded with each of the steps and finally identified for its divisibility by 11 or not. So let's take an example problem. So this is my example problem 273438. This value has totally 1, 2, 3, 4, 6 digits. So it is a 6-digit number. So let's start with step 1 for checking for this number for its divisibility by 11. So I want to know whether this number is divisible by 11 or not. So I proceed with step 1. My step 1 says that sum up all the digits at odd places. Now what are the values in the odd places? 2, 3 and 3. because my first place and this is my third place, this is my fifth place, and there's no seventh place. So these are the odd places where I identify the values. So my first place is with 2, third place is with 3, and my fifth place is with 8. So I sum up all the digits at odd places. Therefore, sum of digits in odd places is nothing but 2 plus 3 plus 3, which gives me 8. So this is the sum of digits in odd places for the given number. So which I got as 8 from step 1. And more important point here is I take the digits taken from left. So when I go with the step 2, my step 2 says that I'm going to sum up all the digits at even places, also taken from left, proceeding from left to right. So I pick all the digits in the even place, where this is in the second place, fourth place, and sixth place of the given number. So sum of digits in even places are already picked here to be 7, 4, and 8. Therefore, when I sum up 7, 4, and 8, I get 11 plus 8, which is 19. So this is how I get summing up the even digits in even places and summing up the digits in odd places, which are 8 and 9. So these are the step 1 and step 2 process which I have used in identifying the number for its divisibility by 11. So now let's go with step 3. My step 3 says that I had to find the difference or the value as obtained in step 1 minus as the value that is obtained in step 2. So the value which I obtained in step 1 is 8 and the value which I obtained in step 2 is 19. So I find the difference of 8 and 19. So when I take the difference, it is nothing but difference of the first step minus second step, so that this gives me 8 minus 19, which on subtraction gives me 8 minus 19 with negative 11, because the highest number is with negative sign. I subtract and give minus 11. So my difference here is negative 11 as I go with step 3. My step 4 says that check for the divisibility of the difference by 11. So whatever difference I get here, I have to check for its divisibility by 11. Now clearly, because 11 is divisible by itself, I can see that this can be written as negative 11 times of 1. Therefore, the difference negative 11 is clearly divisible by 11, which clearly holds from step 4. So this number, the difference negative 11 which is obtained, is clearly divisible by 11, because simply negative 11 can be written as negative 11 times of 1. Every number is divisible by itself. This is the property I used here. Now, once with the 4 steps, I conclude that the whole number is said to be divisible by 11 if the difference is also divisible by 11. So using this property, now since the difference is clearly divisible by 11, therefore the whole number, which I call it as 273438, is divisible by 11, as can be seen through the general division which we can do by dividing this with this and checking for the remainder to be 0 or not. Will make us understand in verifying the given rule for its own process. So this is how the divisibility rule for 11 is proceeded with from step 1 to step 4 as taken in each of the cases. Step 1, step 2, step 3 and step 4 are the 4 steps involved in identifying any given number to be divisible by 11 or not. So we have discussed already in the previous session about divisibility by 7 for a 3-digit number. But if the digits are very large, say for example, I have a number 75388768849, which has totally 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is a 10-digit number which I want to identify for its divisibility. So let's start in the session with the heading divisibility by 7 for very large numbers. So in case of this number, the divisibility by 7 rule has its own limitation, because for a 3-digit number, it is easy to construct in an expanded form, as we have seen in the previous case, that a 3-digit number x can be written as 100a plus 10b plus c, which can be nearest in multiples of 7. But in case of a 10-digit number, I cannot imagine taking a number in expanded form. It becomes a very enlarged, time-consuming process. Therefore, that method may not be a suitable method for a number which is very large. So let's have another alternative method through which I can identify a 3-digit number. I can identify a number to be divisible by 7. So in this case, my first step is about taking each of the 3 groups starting from right. I take all the 3 digits as one group. So when I proceed from right, my digits 9, 4 and 8, 9 in the units place, 4 in the tens place, 8 in the hundreds place. So the last 3 digits, I take it as group 1. Then I take the next 3 digits which I form as group 2. Then I take the next 3 digits which I form as group 3. So I group them in such a way that each of the group has 3 digits when I proceed from right to left. Now when I have group 1, I have 3 digits, 8, 4 and 9 in group 1, 8, 7, 6 in group 2, 5, 3, 8 in group 3, taken from right to left in order. So 3 of them, 3 of them and 3 of them, and the last digit is only one single digit which I independently take as group 4. Now group 4 has only one digit, which is 7. So this number is divided totally into 4 groups, where group 1, group 2, group 3 and group 4 are taken accordingly from right to left. Now once the groups are formed, I separate the groups in such a way that I get this to be 7 is one group, 538 is another group, 876 is another group, and 849 is another group. So breaking up of each of the groups is what I do, so that I differentiate each of the groups through the breaking up in this manner. So to check for divisibility of 7, my step 1 is about breaking into groups of 3 starting from right to left, and my step 2 is about picking up the last and the alternate groups. Picking up the alternate groups. So once I pick the alternate groups, my group 1 is picked with group 2, group 3. Group 1 is paired with group 3, and group 2 is paired with group 4 as I proceed from group 1, group 2, group 3 and group 4. So this would be group 2 is paired with group 4. Repeat. Now as I pair group 1 with group 3 and group 2 with group 4, then I am going to add group 1 and group 3. Then let's see what I get in case of adding group 1 and group 3. So when I add group 1 with group 3, so my group 1 is with value 849, and when I add group 3 to it, I get 538, and when on addition, it gives me 16 times 17, 7, 4, 8, 10, 39. So this is the value I obtain when I add the value as obtained in group 1 with group 3. Now similarly, I take group 2 added with group 4. Now my group 2 is 876 and my group 4 has the value 7. So I add accordingly 876 plus 7, which gives me 883. So these are the values I obtain in group 1 plus group 3, and this is the value I obtain when I add group 2 to group 4, and this is the value I obtain when I add group 1 with group 3. Now when I got these two values, then I just subtract one from the other. I just subtract 883 from this number. So as I subtract 883 from this, I get 1387 minus 883. When on subtraction gives me 7 minus 3 times 4, 0, 13, 504 is the value I obtain when I subtract 883 from 1387. Now the subtraction is from each of the values as obtained from adding group 1 with group 3, which gave me 1387, and adding group 2 to group 4, which gave me 883, and the difference which has given me 504. So my divisibility rule says that, therefore, clearly 504, let's check for its divisibility by 7, which can be checked either by using the process of 100A plus 10B plus C as done in the previous session, or randomly verifying, because I think a 3-digit number division is not so prolonged, can be used with the general division method. So let me just divide this with 7, where I get 7 7s 49 and 14, 7 2s 14, where 0 is the remainder. Therefore 504 can be expressed as this. Clearly, because it's a multiple of 7, 504 is divisible by 7. So 504 is clearly divisible by 7 because it can be expressed as factor of 7. 72 times of 7 is 504. So when this number is divisible by 7, the number as obtained through all the steps, then indirectly I can say that, therefore, the 10-digit number which is given out here, therefore 7538876 is divisible by 7 using the divisibility process for 7 by using this concept for very large numbers. So divisibility by 7 for large numbers is taken into consideration with step 1, where we group them in 3 digits taken together from right to left, and each of the groups taken from right to left, group 1, group 2, group 3 and group 4, I add the first and the third group, then add the second and the fourth group, then I subtract the values, and the number is obtained. If this is divisible by 7, then my whole number is said to be divisible by 7, is how I understand the divisibility by 7 for large numbers.